Hi everyone, welcome back. Let's see various modes of CPU. Guys, in general, if you take the operating system is a kind of a software, which means it's a collection of set of programs or set of lines of code. These set of lines of code are meant for to work with various resources of the computer, right? Means this set of lines of code is able to allow to work with memory parts of the system, or which is able to work with to connect various kind of peripheral devices, right? So not only this, we will have many things are there, right? So that is the advantage of this operating system software. But can we able to, as a user, can we able to allow to manipulate them directly? No, it couldn't possible. It couldn't possible. Suppose for example, if you are the person allowed to modify this software, allowed to modify this software, something like some instruction one c equal to a plus b as c equal to a minus b, right? In general, if a particular user trying to access particular requirement, instead of performing addition like a equal to 5 b equal to 2, if they are asking for addition, something like you need to get the value as equal to 7, but as a user he is expecting the value 7, but internally one user already modified this code, so he will get the result as c equal to 3, right? Which is actually a wrong requirement. Am I right? That means, observe here, when a particular user allows to modify the software directly, it will be affect to the all kind of resources of the computer. So you should not allow to modify the operating system code or some kind of instructions should not execute directly by the end user, right? What will happen if I am going to allow to the executing certain kind of privileged instructions? These kind of things will impact, right? So that is the reason operating system developers comes with two modes of CPU. One will be user mode and another will be kernel mode, guys. So in general, all kind of privileged instructions means, let's say if a particular instruction is directly work with various resources of the computer, those instructions we can call it as privileged instructions, right? In kernel mode, all the privileged instructions are going to be executed, right? So here in general, if I say here we are going to execute various kind of instructions who are the privileged users, means who have the admin rights, all those things, those users will be executed in the kernel mode. But in user mode, here also we are going to execute the instructions who are having non-privileged users, or they might be privileged users. That depends upon their interest. If they want to execute the normal code, they can execute in the user mode. If they want to execute certain kind of privileged instruction, they have to execute definitely in the kernel mode, right? For example, For example, if I have a code something like this, void main, and I am going to have certain set of instructions. This logic is related to performing addition of two numbers. That's it. Guys, try to observe here. In this particular example, have we written any kind of a code which is related to the operating system? No. As we haven't written any kind of code which is related to operating system, that will be directly executed in only user mode. User mode. For example, if I say void main and I have some set of instructions and I have a system call, fork is system call, and I have again set of instructions. I'm closing off this program. Right, guys, you already know fork is a kind of system call which is provided by the operating system, which will executed in the kernel mode. Kernel mode, right? So this particular program is start executing from top to bottom. So while trying to executing, it encounters a fork method, right, which is a kind of system call, right? So up to here, it is executing the user mode. Once you click into the system call, it got converted into kernel mode. So because it's a kind of privileged instruction, So this fork, I can call it as a system call, or I can call it as a supervisory call, or I can call it as a privileged instruction. Right? What might be non-privileged instructions? So non-privileged instructions means those can be something like performing addition, subtraction, like that. They will become under non-privileged instruction. Yes. Okay, fine. So what I am trying to say here, your program starts executing. Initially it is in the user mode. Once it encounters a fork system call, it will be entered into the kernel mode. Once it performs its task, again control will get back to the earlier mode, that is into the next instruction, and again it is going to execute. This is what user mode, right? So in general, so if you are trying to switch from kernel mode to user mode and user mode to kernel mode, then we can call this particular procedure as mode shifting operating system, right? You are trying to shift the modes from kernel mode to user mode and user mode to kernel mode, right? So here, so in general, how operating system will identify whether it is a kernel mode or user mode means, so by noting of some kind of mode bit data, right? This mode bit can be a 0 or a 1. If the mode bit is 0, which represents it is in a kernel mode. Mode bit is 1, which represents it is in user mode. Right, guys? So we can simply indicate that when mode bit value is 1, it indicates that I am in the user mode, and when mode bit value is 0, it is indicating that I am at the kernel mode. Okay, fine. So when you are trying to work something on the user mode, is it directly affected to the operating system resources? Are you directly working with operating system resources? Definitely not. That's the reason we can say user mode as the safest mode. But coming to the kernel mode, when you are trying to work with instructions or executing instructions in the kernel mode, they are directly affecting the resources. Am I right? Yes. When they are directly affecting the resources, it will be, we can call it as risky mode, or it is non-safe mode. Non-safe mode, which I can say in other words, safest mode means actually we are trying to execute certain set of instructions in C language, which you might have idea in C language. At certain point of time, you encountered an error. When you encountered an error, is the entire system is going to be halt, or only this particular program will stop executing? Program will stop executing and will throw errors. Am I right? That is one more advantage of the user mode. But when you look into the kernel mode, if you are trying to execute the instructions, if any error happens, entire system is going to be crash, or I can say that entire system is going to halt, won't work, because we are working with kernel mode, right? That's the reason we can say that it is non-safe mode or risky code. And one more important, guys, the point is here, initially when you turn on your system, all bootstrap program is going to start executing, which I can call it as BIOS, which is actually available in the ROM. And then it is going to load kernel into the main memory, guys. And this unloading of the kernel will be done once you turn off your system. Then only it is going to be unload, right? What does the kernel contains? Kernel contains all kind of operating system code, right? Which we can say that as privileged instructions, right? So if you look into the exact structure, how it is shifting from user mode to kernel mode, yes, observe here. It is a kind of a CPU where you have user mode and the kernel mode. Generally your program is executing in the user mode. When you encounter a system call, automatically control will be transferred to the kernel mode. Means here the mode bit is going to be 1, and here the mode bit 1 will be modified as 0, while transferring call from user mode to kernel mode bit is going to be a 0. Once it executes its particular requirement, and then it's going to give response in the form of a return type, and then it is going to execute the remaining set of instructions. Now again the mode bit will be 1. This is the way shifting is going to be happen between the user mode and the kernel mode. Hope you understood this video clearly, guys. Thank you.